Hello and welcome to another session in physics. In this session, we'll be looking at the topic Newton's laws of motion. But before that, let us review the previous lesson. Welcome back. At this point, let's talk about Newton's first law of motion. Of course, as a very good physics student, the name Newton should not sound strange to you. This was from Sir Isaac Newton. Isaac Newton was a man who was fascinated with the movement of objects. In fact, he was so fascinated that he was the one that discovered the law of gravity. He was able to propound a theory for that and explain why every object that goes up has to come down. And that's what you will learn as Newton's universal law of gravitation in SS3. But at this point, let's get ourselves acquainted with Newton's three laws of motion. The first law is the law of inertia. Now, Newton's first law is stating that a body will continue in its state of rest or of uniform motion in a straight line unless it is acted upon by an external force. In other words, if you are to kick a football, that football will continue rolling and rolling and rolling until somebody traps it and makes it come to a stop. Or air resistance causes that football to stop. That is what we mean by Newton's first law of motion. Now, this simply means, like I've already explained, that a body at rest will continue remaining there permanently. If you keep your book on your desk, your book will remain on your desk unless somebody comes there and removes it. Similarly, if a body is to move, that body will keep moving in a straight line, or it will continue moving forever if that were possible, unless all external opposing forces are to be eliminated. So in the presence of external opposing forces, definitely that body will have to come to rest at some point. Now, this tendency of a body to move or to remain at rest is what we call the inertia of the body. And that is why Newton's first law is also referred to as the law of inertia. Now, there are some consequences that are associated with this law. For example, let's say a car has a head-on collision with another driver. In other words, two drivers are coming in opposite directions and they are to collide with each other face to face, and one of the drivers suddenly applies a brake. Something is going to happen. The passengers in the vehicle are likely to be injured because with the sudden application of brake, they might fall backwards and they might fall forwards rather and hit the windscreen, especially the driver. The driver might have to hit his head on the steering wheel or on the windscreen. That is the reason why passengers are asked to use safety precautions such as a seat belt. Also, if a car that is parked had some people inside it and from nowhere, all of a sudden, out of the blue, another car comes and knocks it forward from behind, because the passengers were taken off guard, they may sustain neck injuries because their bodies will tend to move forward but their neck will move backwards. That is what happens because of inertia. But modern cars today have therefore provided head rests in order to prevent this incident from happening. So the headrest is to prevent your neck from bending backwards if you were to accidentally been hit by a vehicle from behind. Now let's talk about Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force and takes place in the direction in which that force acts. So what this second law is trying to say is that it's implying that when a heavy body and a light body are acted upon by the same force for the same time, the light body will build up a greater velocity than the heavy one, but both of them will gain the same momentum. Yes, when the same force acts on two bodies at the same time, a heavy one and a light one, the light one will build up a greater velocity and the heavy one will build up a smaller velocity due to its increased or heavier mass. Now let's talk about impulse. Now impulse simply refers to the force that is acting on a body for a given period of time. A force acting on a body for a given period of time. We can also say that impulse is equal to the change in momentum, and it also shares the same unit as momentum, which is Newton second. They share the same unit, which is Newton second. So Newton second is the unit of momentum. At this point, let's talk about Newton's third law of motion. Now, Newton's third law of motion is my favorite law. It states that action and reaction are equal. So what it simply means is that to every action, there is an equal but opposite reaction. In other words, when you place a book on a table, the downward weight of that book is balanced by the upward reaction of the table on that book. So while the book is acting downwards on the table, which is a flat surface, the table on the other hand is also acting upwards in order to support the weight of that book that is lying on top of it. The same way too, when you hit your fist against the wall, you're going to feel pain as well, because the force between your fist, which is acting on the wall, is also being countered by an opposing force from the wall to your hand. Now, according to Newton's second law of motion, force is proportional to change in momentum. Therefore, the momentum of a bullet is equal and opposite to the momentum of the gun. As you can see from the equation we have here, mass times velocity is the derivation for momentum. So basically, what we're trying to say is that momentum is given by mass times velocity. Now, what it simply means is that mass of the gun times velocity of the gun is equal to mass of the bullet times velocity of the bullet itself. So this is a clear explanation of Newton's second law of motion. Now let's talk about conservation of linear momentum. The principle of conservation of linear momentum states that when two or more bodies collide, their momentum remains constant, provided that there is no external force acting on the system. Now this implies that in a closed or isolated system where there are no external forces, the total momentum after collision remains the constant with the momentum before collision. This principle is true for both elastic and inelastic collision. Now, what is elastic and what is inelastic collision? When we talk about elastic collision, we're simply trying to speak about a situation where two bodies move with different velocities. When this happens, both the momentum, which is a product of mass and velocity, and the kinetic energy of that body are conserved simultaneously. This happens in the collision between gaseous particles, or when a ball that has been kicked bounces on the ground and rebounds to its original height. Now, if the two bodies that are colliding with each other have masses m1 and m2, and they have initial velocities u1 and u2, and they have final velocities v1 and v2, the conservation principle can be mathematically expressed as m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Of course, you know, mass m1 is the mass of the first body, u1 is the initial velocity, m2 is mass of the second body and the final velocity, and then the same applies to m1 v1 and m2 v2 as well. Right? Okay, let's look at this diagram. This is the diagram of perfectly elastic and perfectly inelastic collisions. In perfectly elastic collisions, the kinetic energy before collision is equal to the kinetic energy after collision. But in perfectly inelastic collision, kinetic energy before collision is not equal to kinetic energy after collision. Since momentum is a vector quantity, all the velocities must be measured in the same direction. This means that we are going to assign positive signs to the forward velocities and will assign negative signs to the backward or opposite velocities. In an inelastic collision, on the other hand, notice that the two bodies are going to join together after collision. They will have the same velocity and momentum, but the kinetic energy, like I showed you, will not be the same. Thus, the conservation principle can be written as this. Take time after this video to rewatch it and compare it with the first equation that I gave you, this and this as well. Compare two of them together. Alright, so let's look at this example. It talks about two moving toys of masses 50 kilograms and 30 kilograms, and that they are traveling on the same plane with speeds of 5 meters per second and 3 meters per second respectively in the same direction. Now, if they collide and stick together, we are asked to calculate their common velocity. If they collide and stick together, we are asked to calculate their common velocity. For us to calculate their common velocity, we're going to need this equation, MA VA plus MB VB. That's the equation we're going to use. Since V is constant to both, it's going to become V. By factorization, we're going to have MA plus MB. So when you multiply both by V, you're going to have MAVA, MBVB, where A and B are the two bodies respectively, body A and body V. So mass times velocity of body A plus mass times velocity of body B. Now we're asked to calculate their common velocity, and this is their common velocity V, which means we're going to have V equal to MAVA plus MBVB, and it's going to be all over MA plus MB. Now let's try to substitute the values for this inside this equation. So we're going to have 50 times 5. The mass of the first body is 50 and the velocity of the first body is 5, plus mass of the second body 30 times velocity of the second body 3, all over MA, mass of the first body 50 plus 30. So we're going to have inadvertently 50 times 5 is 250 plus 30 times 3 is 90, all over 50 plus 30 is 80. So we're going to have 250 plus 90 is going to give us 340 divided by 80. So when you divide here, you're going to have your answer in decimal. It will be 4.05 meters per second. This is their common velocity. Now, if that isn't clear enough, let's look at this second example. It says a gun of mass 100 kilogram is fired from a bullet of mass 20 grams at a speed of 400 meters per second, and we're asked to calculate the recoil velocity of the gun. Now remember that it's going to become momentum of the gun is equal to momentum of bullet. Momentum of the gun equals to momentum of bullet. So what it simply means is mass times velocity of gun equal to mass times velocity of bullet. So mg vg equal to mb vb. So we're going to have making v the subject of the equation, but before we get to that, the mass of the gun is 100 times v, because we're looking for the velocity of the gun, but the mass of the gun is 100 kilogram, and then the mass of the bullet is 20 grams. 20 grams converting it to kg is going to give us 0.002 times 400, and we're going to take proportions. Taking proportions, making v the subject of the formula, means we are going to divide both sides by 100. 100 will cancel 100, so v which is velocity of the gun, is going to give us 0.002 times 400 all over 100. 2 zeros down will cancel 2 zeros up, and our answer is going to become the velocity of the gun, Vg, equal to 0.002 meters per second, or velocity of the gun equal to 2.0 times 10 raised to the power minus 3 meters per second. And that is the answer to this question. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on